This conference will now be recorded. This conference will now be recorded.
Good afternoon, everyone.
Good afternoon.
Good afternoon, ma'am.
Good afternoon, ma'am.
Good afternoon.
Yes, last class we started with methods of expressing concentration of the solutions. So concentration of an analyte in a solution can be expressed by more than one method depending upon the type of analysis carried out. So we have seen 10 methods of expressing the concentration. So under that we have already seen. So which are the different methods we have seen? Can anyone name?
Ma'am, weight by volume method, weight by weight, volume by volume, mole, fraction, thermal, molarity, normality, formality, molality, and ppm.
Only that's it? All 10 you said?
Yes, ma'am.
Okay, good. So which all we discussed last class?
Ma'am, numerical problems with molarity.
Okay, we have already finished percent by mass, percent by volume.
Yes, ma'am.
So we have seen percent by mass, percent by volume, molarity or molar concentration. So we have finished till here. Yes or no?
Yes, ma'am.
So next is normality. So I had given some problems. Have you completed it, everyone?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes,
Yes, ma'am.
Yes,
Which
ma'am.
method you followed? Formula method or whatever is given, that method.
Formula method.
Formula method. Your
So we'll
method.
discuss it at the last moment. So today we'll start with normality. So normality, its symbol is capital N. So it is defined as the gram equivalent weight of solute dissolved in 1000 ml of solution, or you can tell 1 liter of solution. So what is mean by gram equivalent weight? So what do you mean by gram equivalent weight? Is it same as molecular weight? Is molecular weight and equivalent weight are same?
No, ma'am.
Yes or no? It's different. So what do you mean by equivalent weight? So equivalent weight is going to change based on the reaction. What type of reaction? So it will be changing. So if you take acid-base reaction, in that case equivalent weight is the ratio between molecular weight and basicity or acidity of acid and base. Or simply you can tell molecular weight divided by number of replaceable hydrogen or hydroxyl ions. That will give you the equivalent weight. So this is normality, whereas molarity, it is just the number of moles. Moles means molecular weight. Just take the molecular weight of the substance and dissolve it in 1 liter of solution or 1 liter of solvent. You get 1 molar. But in normality, it is gram equivalent weight of solute dissolved in 1 liter of solvent. And normality is calculated by using which formula? N1V1 is equal to N2V2. So N is equal to the number of equivalent weight of solute divided by volume of solution in liters. So gram equivalent weight is equal to mass in grams divided by equivalent mass. So By substituting, the normality will be mass of solute in grams divided by equivalent mass into volume of solution in liters. So this is the formula of normality. So we have taken one example. So calculate the normality of 0.53 grams of 100 ml solution of sodium carbonate, and the reaction is sodium carbonate plus 2 moles of hydrogen will give you what is H2CO3. What do you mean by H2CO3? Yes,
Sodium
carbonic
carbonate.
acid, H2CO3. It is
Bicarbonate acid.
carbonic acid. So sodium carbonate reacts with hydrogen to give you carbonic acid and 2 sodium ions. So what is we need to find out is normality of the solution. So what is the equivalent or weight of sodium carbonate? Molecular weight divided by its. So sodium carbonate is acid or base?
Acid.
Na2CO3, sodium carbonate. Whether it is an acid or base.
Acid.
Acid.
Sodium carbonate is acid.
Base.
Base, ma'am.
How many of you go for acid? How many of you are going for base?
Base, ma'am.
Base.
It's a base.
Yes, ma'am. It's a base.
So based on what you are telling, it is acid or base.
Ma'am, it can't donate
Ma'am, it is.
hydrogen in aqueous.
Ma'am, it is.
It is.
Ma'am, it is basics because sodium carbonate is formed by reacting NaOH and H2CO3. So NaOH is strong base and H2CO3 is weak base. So Na2CO3 is basic in nature.
Okay. It is actually sodium carbonate is basic. So the molecular weight of sodium carbonate is 106 grams. And why you are dividing it by 2? Why you are dividing it by 2? Since equivalent weight is molecular weight divided by its basicity or acidity. That is number of replaceable hydrogen or hydroxyl ions. So you can see sodium, 2 sodium ions are replaced by 2 hydrogen ions. Hence, the molecular weight should be divided by 2. Sodium carbonate 106 divided by 2. So it will become 53 grams. So 53 grams is equivalent weight. So you can substitute it in the formula. Normality is equals to 0.53 grams divided by 53 into 100 ml into 1 liter by 100 ml. So 0.1 equivalent per liter. So this is the one example. Now, how will you prepare one normal sodium hydroxide solution? Yes, how will you prepare one normal sodium hydroxide solution? So to prepare one normal sodium hydroxide solution, what you need to know before preparing its molecular weight, its equivalent weight. So what is the molecular weight of sodium hydroxide?
40.
40 grams.
40.
Ma'am, 40.
Yes. What is the equivalent weight of sodium hydroxide?
20.
Why 20? What is the formula of sodium hydroxide? NaOH. Yes, sodium hydroxide. Sodium hydroxide is a base. So what is acidity? Acidity is the number of replaceable hydroxyl atoms present in a base. So how many replaceable hydroxyl ions present in a sodium hydroxide?
1.
1.
1. So equivalent weight will be molecular weight divided by 1. So 40 divided by 1 is
40.
40.
40.
So sodium hydroxide has both molecular weight and equivalent weight same, since its number of replaceable hydroxyl ion is 1. So one normal solution or 1 molar solution is one and the same. There is no difference. So just you have to take 40 grams of sodium hydroxide and dissolve it in 1 liter of water or 1000 ml of water to get one normal solution or 1 molar solution of sodium hydroxide. Now can you tell me for hydrochloric acid?
Excuse me, ma'am.
Yes.
Ma'am, can you repeat it again? Because there was a lot of lagging.
Okay. Sodium hydroxide has same molecular weight and equivalent weight. So molecular weight is what is the exact molecular weight of the substance, that is molecular weight, whereas equivalent weight means molecular weight divided by number of replaceable hydrogen or hydroxyl ions. So here sodium hydroxide is a base and its formula is NaOH. So it contains one replaceable hydroxyl ion, that is OH ion. So molecular weight divided by number of replaceable hydroxyl ion is 1. So 40 divided by 1 is 40. Hence, the molecular weight and equivalent weight of sodium hydroxide is one and the same. So whether you say normal solution or molar solution, it will be same. So to prepare one normal or 1 molar solution of sodium hydroxide, you need to take 40 grams of sodium hydroxide and dissolve it in 1 liter or 1000 ml of water.
Got it, ma'am.
Clear? Okay. Next, can you tell the hydrochloric acid molecular weight?
36.46.
That is 36.5. You can round it off. So what will be the equivalent weight of hydrochloric acid?
Ma'am, same.
Same 36.5.
5.
Yes.
Because
Because
the number of replaceable hydrogen ion in hydrochloric acid is 1.
1.
So molecular weight divided by 1, 36.5 divided by 1 is 36.5. So if you want to prepare one normal or 1 molar solution, you need to take 36.5 grams of hydrochloric acid in 1 liter or 1000 ml of water. Now tell me about sulfuric acid. Yes, molecular weight of sulfuric acid is how much?
90.
98.
Yes, 98 grams. 98 grams is the molecular weight of sulfuric acid. Now what is the equivalent weight of sulfuric acid?
49.
49.
Why?
2 replaceable hydroxyl ion are present.
Because it has 2 replaceable hydrogen ions, H2SO4. So 2 hydrogens can be replaced. Hence molecular weight is divided by 2. So 98 divided by 2 is equal to 49 grams. So 49 grams of sulfuric acid is dissolved in 1000 ml or 1 liter of water to get 1 normal solution. If you want 1 molar solution, then it should be 98 grams of sulfuric acid in 1000 ml or 1 liter of water to get 1 normal solution. So here there is change in strength, normality and molarity. Similarly, for calcium hydroxide, what is the molecular weight of calcium hydroxide? Calcium hydroxide molecular weight is 74 grams. Calcium hydroxide molecular weight
74.
yes 74. What is the equivalent weight?
Same, ma'am. 74.
74 calcium hydroxide
74, ma'am.
24, ma'am.
no.
37.
Calcium hydroxide is 37 because
2
calcium
OH.
hydroxide, the basicity of calcium hydroxide is 2.
2.
So 74 divided by 2 is 37. So 37 grams of calcium hydroxide is dissolved in 1 liter or 1000 ml water to get 1 normal calcium hydroxide solution. So when we talk about salt, then it will be different. Equivalent weight of a salt. So what happens for equivalent weight of a salt? It is the ratio of molecular weight to valency. It should be divided by the valency of the salt. So if you take sodium carbonate, so sodium carbonate, its molecular weight is how much? Sodium carbonate 106. So sodium carbonate molecular weight is 106 and the valency of sodium is 2. So it will be 106 divided by 2, that is 53 grams. So 53 grams of sodium carbonate is dissolved in 1000 ml of water to get 1 normal solution. What about oxalic acid? What is oxalic acid? Anyone know? The formula, molecular formula of oxalic acid?
C2H2O4.
C2H2O4, that is nothing but COOH twice. That is oxalic acid. So this oxalic acid, what is the molecular weight?
.90.
90.
90.
Ma'am,
In
90.
laboratory, we have oxalic acid dihydrate. So what will be the oxalic acid dihydrate molecular formula? Dihydrate means 2 molecules of water.
126.
Yes, 126 grams is the molecular weight of oxalic acid. Now what is the equivalent weight of oxalic acid?
63.
3
Yes,
grams.
why it is 63?
Because 2 H plus, 2 replaceable
Yes,
H plus.
it has 2 replaceable hydrogen ions. So oxalic acid equivalent weight is molecular weight divided by number of replaceable hydrogen ions, that is 126 divided by 2, it is 63 grams. So take the question.
Ma'am, can you repeat it again, ma'am?
Which one? Oxalic acid.
Yes, ma'am.
So oxalic acid dihydrate is the available chemical in the laboratory. So we need to calculate for oxalic acid dihydrate molecular formula, molecular weight. So oxalic acid dihydrate molecular weight is 126 grams and equivalent weight is molecular weight divided by number of replaceable hydrogen ions. Oxalic acid has 2 replaceable hydrogens, hence its molecular weight should be divided by 2. So 126 divided by 2 will be 63 grams. Hence 63 grams of oxalic acid dihydrate is dissolved in 1000 ml or 1 liter of water to get one normal solution.
Thank you, ma'am.
Yes, take down the question. How many grams of oxalic acid? How many grams of oxalic acid is required to? How many grams of oxalic acid is required to prepare? How many grams of oxalic acid is required to prepare? Required to prepare 0.5 normal, 0.5, that is 0.5 normal, 750 ml solution. 0.5 normal, 750 ml solution. So you want to prepare 0.5 normal 750 ml oxalic acid solution. So first we need to know how will you prepare one normal oxalic acid solution. How will you prepare one normal oxalic acid solution? 63 grams of oxalic acid in 1000 ml water. What you get?
1 molar.
1 normal. Now X grams of oxalic acid in 1000 ml water to get
0.5 Newton.
0.5 normal.
Normal.
So
Normal.
X is equal to 1000 get cancelled. So it is 63 into 0.5 whole divided by 1.
1.
So what will be the answer?
31.5.
31.5.
Ask.
31.5.
31.5 grams.
Gram.
So now 31.5 grams of oxalic acid in
1000
1000 ml
Water.
water. You get
0.5.
0.5 normal
normal.
solution. Again, X grams of oxalic acid in how much?
750 ml.
750 ml water. So you get
0.5 normal.
0.5 normal. So now 0.5 will be cancelled. So X is equal to 31.5 into 750
Divided by 1000.
divided by
1000.
1000.
23.6.
23.6.
23.625.
So how much you get?
Yeah, ma'am. 23.6 gram.
23.625.
23.625.
23.6 gram. 625.
3.62.
Yeah, ma'am.
So we'll round it off to how much? To do after
23.62.
24.
after decimal 2 digits. So it is 23.63. Yes, 63. So after 2 we have 5.
63.
So 2 will be changed to 3. If you want to round it off to only 2 digits without decimal, so it is rounded off to 24 grams or 23.6. So depending on what balance you are using. So what digits balance you are using, you can round it off. So 23.63 grams of oxalic acid is dissolved in 750 ml of water to get 0.5 normal solution. So everyone understood how to calculate?
Yes, ma'am.
So similarly, how I had done sodium hydroxide, you can calculate for oxalic acid, but please mute yourself. So similarly, you can calculate for various concentrations. So similarly, how we discussed for sodium hydroxide, you can write various strengths, different concentrations and different volumes you can prepare. So now we'll move on to preparation of hydrochloric acid. So how will you prepare one normal hydrochloric acid? So how will you prepare one normal hydrochloric acid solution? Yes. How will you prepare 1 normal hydrochloric acid solution? What is the molecular weight, equivalent weight of hydrochloric acid?
36.5.
36.5.
36.4.
So molecular weight and equivalent weight is one and the same for hydrochloric acid. It is 36.5. And what is this 36.5 is?
Molecular weight.
Grams. So hydrochloric acid is a solid or liquid?
Liquid.
Liquid.
Liquid,
So,
ma'am.
how will you take this 36.5 grams of HCl then? Will you weigh? Are you going to weigh or are you going to measure the volume?
Measure the volume.
HCl. So how will you convert the gram into ml? How will you convert gram to ml? What can be used? So which formula will have? Density. Density is equal to mass by volume. So mass by volume means it will be given gram per ml. So what is the density of HCl? Density of HCl is 1.2 gram per ml. So density of hydrochloric acid is 1.2 gram per ml. What do you mean by 1.2 gram per ml? What does it indicate? If you take 1 ml, it will be 1.2 gram. Now, so X is equal to 1 ml is equal to 1.2 gram. So how much ml will be 36.5 gram? Cross multiply. X is equal to 36.5 into 1 divided by 1.2.
30.1, ma'am.
43.8, ma'am.
30.41.
Yes.
30.1.
30.41, ma'am.
30.41.
36.5 divided by 1.2 is how much?
30.41, ma'am.
30.41, ma'am.
30.4166. So it is rounded off to 30.42. So this is ml. So if you want to take 36.5 grams HCl, how much you need to take? 30.42 ml. But there is one more problem here. So what is that? Purity. So purity of HCl. So what do you mean by purity? So whatever the hydrochloric acid we are getting in the laboratory is having only 36%. So what do you mean by 36% purity? So if you take 100 ml of hydrochloric acid solution from that bottle, it contains only 36% of hydrochloric acid. So now you need to take 30.42 ml of hydrochloric acid. So if you take 100 ml, it will be 36%. So how will you convert now?
36 by 100 into 30.42.
So how much will you take now? Yes, x is equal to 100 into 30.42 divided by 36. So what it will be? How much?
Eighty-four.
84.5, ma'am.
Yes, it is x is equal to 84.5 ml. Yes. Now, how much you need to take hydrochloric acid? 84.5 ml of concentrated hydrochloric acid is dissolved in 1000 ml or 1 liter of solvent to get 1 normal or 1 molar solution. So 84.5 ml of is dissolved in So 84.5 ml of hydrochloric acid is dissolved in 1000 ml water to get 1 normal or 1 molar solution. So understood how the calculation is done?
Yes, ma'am.
So you should know density and purity if you take a liquid. So because molecular weight and equivalent weight is expressed in grams. So we need to convert gram into ml. So take the question now. So you have to prepare 0.2 normal, 0.2 normal, 500 ml hydrochloric acid solution. Prepare 0.2 normal, 500 ml hydrochloric acid solution. Do the calculation and tell me the answer. Done? Got the answer? Yes. Finished calculation, tell the answer.
3.6 something.
3.6 something. You're not sure.
Ma'am, 3.65 grams.
Grams. I want in ml.
Ma'am, 4.38 ml.
Okay, only one. Everyone got? How will you do? What was the question? You want to prepare? 0.2 normal?
3.65.
No, what was the question? 0.2 normal? 500 ml solution? Yes? This
Ma'am.
was the question, right? So, first we know that 84.5 ml of HCl is dissolved in 1000 ml water to get one normal solution. Now, X ml of dissolved in 1000 ml to get 0.2 normal. Now, X is equal to how much? (84.5) into 0.2. So how much it is? X is equal to
16.9.
16.9. 16.9 ml. Yes. Now 16.9 ml in 1000 ml, you'll get 0.2. Now again dissolved in how much?
500.
So what will be the now? 0.2 gets cancelled and it is 16.9 into 500 divided by 1000. So it is x is equal to
8.45.
8.45 ml. So everyone got this?
Yes,
ma'am.
Okay.
Yes, ma'am.
So now understood how to prepare the various solutions, different strengths,
Yes, ma'am.
different.
Yes, ma'am.
Okay. So we'll check the last class answers. So what is the first answer?
Ma'am, 2.5.
22.5 gram.
22.5 gram, ma'am.
You have not checked whatever answers you are telling here. I check it later on. Everyone got the same?
Yes, ma'am.
Okay. What is the second one?
Yes, ma'am.
Ma'am, 10
10
gram.
10 grams.
10
10
gram.
gram.
10
10
gram.
gram.
10 grams.
Okay. What
10
is
grams, ma'am.
next one?
Ma'am, 7.5 gram.
7.5 grams.
7.5 grams.
7.5.
7.5 grams.
7.2.
Okay. Next.
8
Ma'am,
grams.
8
8
grams.
gram.
8 grams. 8 grams.
8
8
grams.
grams.
1 gram.
ma'am, 1.
1 gram.
1
1
gram.
gram.
1 gram, ma'am.
1 gram.
1 gram,
1
ma'am.
Everyone
gram.
has got the same answer.
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Okay. Whichever
Yes,
method
ma'am.
you do, either in the formula method or in this method, so you are okay?
Our method, ma'am.
Ma'am, formula.
Okay. Any method, you are getting the same answer, right?
Yes, Yes, ma'am.
Yes,
Yes,
ma'am.
Um,
Okay. Well understood. So take on some more homework for today.
Okay.
No, not calculate. So you have to prepare
ಎಲ್ಲಿಗಮ್ಮ ಏನಾಯ್ತಂತೆ ಏನ್ ನೋಡ್ತೈತೆ ಅದು ಇದು ತಿನ್ಬಿಡ್ತಾನೆ
So can you see my screen?
Yes, ma'am.
Yes, ma'am.
So these are the homeworks for today.
And purity of sulfuric acid.
98%. So all normality I have given, not molar. So from tomorrow you have an holiday for 1 week till November 2nd. You don't have any online classes. You can enjoy your Dasra holidays.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you, ma'am.
And purity of NaOH.
Actually, purity of NaOH is also 98%. But since it is a solid, we are not going to much this one. While preparing the solution, we'll be taking little excess of sodium hydroxide. It is an hygroscopic solid. What do you mean by hygroscopic? It is going to absorb the moisture and it is going to liquefy. The solid is going to be melted due to the absorption of moisture or oxygen in the atmosphere. So shall we end the class now?
Yes, ma'am.
If you have any doubts,
Ma'am.
we'll discuss in this. Yes. So if you have any doubts, we'll discuss in the next class. That is November 2nd, your online class starts.
Monday there is working day.
What is?
Monday there is working day. Monday.
For teachers, college, no holiday. Only for the students, online class, it is holiday. The college will be open. Teachers will be coming to college. Only
Okay.
for students, online classes, it is holiday.
Okay.
Excuse me, ma'am.
Yes.
Ma'am, give your homework. We also calculate the purity form also, ma'am, in this homework.
Sorry, I didn't get.
Ma'am, we gave you homework now, ma'am. We also calculate on purity form also, ma'am.
We also
Calculate purity form.
sulfuric acid and hydrochloric acid purity form, not sodium
Yeah.
hydroxide and organic acid.
Okay.
Ma'am, how the impurity is calculated?
How the
Impurity, how the purity is calculated of HCl, H2SO4 like liquids?
we have different analytical methods. So in water they'll be giving. They'll be analyzing that and they'll be giving.
Okay. Ma'am, can you please tell the purity of NaOH and H2S?
NaOH I said no, 96 to 98%. Depending on the which brand you are taking, which chemical you are taking. Okay, calculate this. Please write it everything in one book. As the college reopens, I will check all this. So all this, what you are writing will carry marks. So I said to keep one separate book. You can write it in that book only. Whatever I am telling, notes, homework. But I'll give the assignment separately after completing this chapter. So okay then, we'll end the meeting now. All of you take care. Bye.
Bye, ma'am.
Bye.
Okay.
Bye, ma'am.
Bye.
Bye, ma'am. Thank you.
Bye, ma'am.